Hi, for this recording, I'm going to show you how to determine the interval of convergence for a power series. So let's go to the PowerPoint slide and view some slide here. So suppose we have a power series summation of an times x minus a power n, where a is the center here. Now this power series, we can find the absolute value of an plus 1 over an as n approaches infinity. Suppose the limit is L. Now, if suppose L is a number greater than 0, then the series will converge for x minus a absolute value less than 1 over L, and the radius of convergence is R equal to 1 over L. And in that case, around the center, the radius of convergence, you find that the series converge on the interval from a minus R to a plus R. So now let's go back to the solution now. So I'm going to n here. So an is equal to minus 1 power n, x power n times n minus 1. Now, let's find the next term. So an plus 1 term will be minus 1 power n plus 1, x power n plus 1 over n plus 1 minus 1 will be n. So the ratio of n plus 1 over an, in this case, I'm sorry that there's no x here, alright? There's no x here. So an will be this. So an plus 1 over n will be, after you take the ratio, you get minus 1 power n plus 1 over n plus 1 times n divided by an. So times n times n minus 1 over minus 1 power n. So after cancellation, you get minus 1, and the cancellation will be n and n cancel. So minus 1 and minus 1 power n cancel, and that's why we get minus 1 left, and n minus 1 times n plus 1. So when you take the absolute value, this will be n minus 1 over, you can say, divide everything by n, you get 1 minus 1 over n over 1 plus 1 over n. And when n goes to infinity, this goes to 1 minus 0, 1 plus 0, which is 1. Now this number, according to PowerPoint slide, is called L. Now L is always a number greater than or equal to 0. Alright, so in this case, L is number greater than 0 now in the PowerPoint slide. So after we know this number L here, we know the radius of convergence now. So radius of convergence. Now for our power series, the center of the power series is 0. Right? Center in this case is 0, x equal to 0. Radius of convergence is 1. 1. So the endpoint of the interval is from minus 1 to 1. That means that the power series will converge for x between minus 1 and 1, and diverge for x greater than 1 or x less than minus 1. Now the question we want to ask is, what about the endpoint? What about when x equal to 1 or minus 1? So when x equal to 1, what will happen? So 1 on the endpoint is x equal to 1. What will happen? Now let's look at the power series again. The power series look like this. It's actually sum of minus 1 power n, x power n, n over n minus 1. So the power series becomes the power series. Okay, let's write down. I'm going to write down in short form. This is a summation of minus 1 power n, x power n, n times n minus 1, and from 2 to infinity, this is the power series. Now becomes, when you put x equal to 1, become like this. 2 to infinity, minus 1 power n over n times n minus 1. Now notice that this is actually an alternating series because the term start with positive, negative, positive, negative, right? So this is an alternating series. This is an alternating series where something like this. You can imagine that this is something of this type of form, alternating, where Bn in this case is a 1 over n times n minus 1. And we know that Bn is decreasing with n, we know. As n increase, n times n minus 1 increasing. So Bn decreasing with n. And also Bn converges to 0, and Bn is null. Therefore, so the series will converge. Right, so this series n from 2 to infinity of minus 1 power n, n times n minus 1, converging by alternating test. So we know that when x equal to 1, the power series converge. Right? When x equal to 1, power series converge. Now how about when x equal to minus 1, the other endpoint? So when x equal to minus 1, let's see what happened to the power series now. So let's write down when x equal to minus 1, the power series we have is summation of n from 2 to infinity minus 1 power n x power n times n over n minus 1 becomes summation of n from 0 to infinity minus 1 power n minus 1 power n over n times n minus 1. Now minus 1 power n times minus 1 power n becomes 1. So this is 1 over n minus 1 from n equal to 2 to infinity. And this series, if you look carefully, this is also the same as the series. Let me write in terms of n equal to 1. Because this is actually 1 over 2 plus 3 times 2, right? Plus 1, 4 times 3, and so on. Right? So 2 times 1. So you can also write them as 1 times 2 plus 2 times 3 plus 3 times 4. Right? So you can write them as a power series in this way. Summation of n from 1 to infinity 1 over n times n plus 1. Okay? And therefore, this power series we know that is as we know that n times n plus 1 is less than or equal to n squared. Therefore, by comparison test now, by the comparison test of power series, we know that since summation of n from 1 to infinity 1 over n squared converge as p series for p greater than p equal to 2 now. So summation of n equal to 1 to infinity 1 over n plus 1 converge. But this series is the same as summation of n from 2 to infinity n times n minus 1 converge. Since they are the same, therefore, when x equal to minus 1, the power series converge. So now we make a conclusion. So we know when x equal to minus 1, the series converge. When x equal to 1, the power series also converge. Therefore, the interval of convergence now, you can write now, the interval of convergence is from minus 1 to 1, including the endpoint. Alright, so it's x between minus 1 to 1, or including endpoint.